Hi everyone, welcome to the new session. I guess I'm visible and audible to everyone. Okay, so in today's session, we are going to discuss about the types of functions. Okay, there are different types of functions, and we will try our best to cover all the types of functions. Okay, which will take time, but in the due course of time, I'm sure we are going to cover most of the functions that are important from your syllabus point of view. Okay, so the first function that we are going to start today is a constant function. Okay, so these all types of functions written here are the elementary functions. Elementary means the basic functions. Even though they are elementary, but they are very important because math is all about learning the basic things and then implementing those basic things to solve the complex things, right? So first we will start with our constant function. Okay, so for constant function here, okay, what is constant function? Okay, so constant function, it is of the type fx equal to k. Fx equal to k, where k is constant, where k is constant. Okay, now here I'm writing f is a function such that it is defined from real number to real numbers. Now see here, what does it mean? Whatever functions we are going to study here, we are going to find our main focus is four things. First is to learn the nature of the function. Second is to draw its graph, to understand the graph. And third thing is the domain and range of the function. Okay, now if I have to draw any function, okay, for example, this is our xy plane. If I have to draw any function on this xy plane, basically what am I doing? I am mapping the value of x with the values of y, right? That's what function is all about, right? For different x, finding different y's and then mapping those values of x with the values of y. So if you look at this xy plane, then x read all the real number values, right? All the values that you are going to read for x, the possible values will be the real numbers. Okay, so whatever value your x is going to take, it can take any real, whatever value it's going to take, it will be the real number. So same as y, so any value that you can see on this xy plane, it's a real value. So that's why I said that f is a function and it is defined such that it is defined from real number to real number. Okay, so here your constant function, it is of the type fx is equal to k. Now let's try to analyze this thing with the example. Let's say that I have fx equals fx equal to. Okay, now fx equal to, okay, this is my x-axis, this is my y-axis. Okay, fx equal to 2, it means y equal to 2, means here I have, if I try to plot the graph for this, so I will get a horizontal line which passes through y at y equals 2. Okay, so what does it mean? It means that you can take any value of x, whether be it negative, okay, because this one is your negative and this one is positive values of x. For negative values of x, you will get the value of y 2, right? And same for the positive values of x, any value, okay, you will get the value of y 2, right? Even on x equal to 0, the value of y is 2. So constant function is the function where if you input any value of x, regardless of whatever it is, negative, positive, or 0, then you will get the constant value of y. So that type of function is known as a constant function. Okay, so if you look here, now, uh, what values of x can it read? Okay, so the values of x that it can read, it's going to be the domain. So what's going to be the domain for this? So domain can be any real number from minus infinity to positive infinity. Okay, so here I'm going to say that my domain is minus infinity to positive infinity, or I can say that my domain, it's going to be or any real number, right? And what's going to be the range of this function? What's going to be the range? Now you can put any value of x, whether negative, positive, or 0. You will get the constant value. Here in this case it is 2, so here the range, it's going to be 2. Okay, so in general, for constant function, if I have to write the domain in general, okay, I'm talking in general, so here I will say domain of any constant function, it's going to be the real number. And what's going to be the range? The range, it's just going to contain one element, and that is the constant value itself. Okay, so that's how we define the range and domain of the constant function. I hope this is clear. Very simple. Okay, now let's jump to the next one. Next one is our identity function. Okay, now what is identity function? Okay, identity function, as the name says, identity means identical. Okay, so see here, what does it mean? Identity function, let's say that here again we have a function f, and it is defined from real values to the real values of y. Okay, and identity functions are of the type fx equal to x. Okay, so fx equal to x is the identity function. Why? Because identity comes from identical, means that your y is equal to x. Okay, or fx is equal to x. Okay, so in this case we are going to analyze the nature of this function, and we will see what's going to be the domain and range of this function. Okay, so fx equal to x, in simple words, what I can do here is that here it can be written as y equal to x. Now, if you look at y equal to x, okay, I'm not sure if you have a little understanding of a coordinate geometry. There, we have an equation of line. Okay, forget about the equation of the line. Now, see here, y equal to x means that any distance that you are going to move towards the left or the right of x-axis, so you have to move the same distance up and down the y-axis. Okay, for example, if you are here at x equal to 0, okay, if you put x equal to 1, okay, or you take value of x equal to 1, then your y is also going to be 1. Okay, so x1, y1, x2, y2, x minus 1, y minus 1. Okay, x2, y minus 2. Okay, then x3, y minus 3, x minus 3, y minus 3. Okay, so if you are going to, what I'm trying to say here is that your fx is equal to, see here, your fx is equal to x. Right now, you can put any value here. F of 1, it's going to be 1. F of minus 1, it's going to be minus 1. F of 2, it's going to be 2. F of minus 2, it's going to be minus 2. F of 3, it's going to be 3. F of minus 3, it's going to be minus 3, right? So whatever value your x will take, y will automatically take the same value. So if you will connect all these points, if you will trace all these points, you will just get a straight line. Okay, you will simply get a straight line. Okay, now see here, this is a straight line. Okay, that's what I was mentioning here before that y equals to x, it represents a straight line, and the slope of this line, because the general equation of line is y equals mx plus c, where m represents the slope. Now the slope of this line, if you compare this equation with this, then the slope of this line is 1. What does it mean? It means that the angle that it makes with the x-axis is 45 degree. Slope means tan theta. Tan theta. Okay, so if your tan theta is 1, it means theta is here 45 degree. Okay, so y equal to x, it represents the straight line which makes angle of 45 degree with the x-axis in anti-clockwise direction. Okay, this is anti-clockwise direction. Okay, now this is your identity function. Very simple. Y equal to x or fx equal to x. Now we are going to identify the domain and range of this function. So what's going to be the domain of this function? Now see here, it's very evident from here that it can take any value on this side, any value of x on this side, and same on this side too. So it can take, see here, now you can take any values on this side from 0 to minus infinity, and same you can take any value of x on this side up to positive infinity. Okay, so for any value on the x side, you will get the same values on the positive y-axis and the negative y-axis. So which means that your domain is going to be minus infinity to plus infinity, or real numbers. Okay, and what's going to be the range? When domain is this, then range is, it's going to be the same, minus infinity to plus infinity, or real numbers. Okay, so this is the identity function. Identity function means fx equal to x, as simple as that. Okay, I hope this thing is clear to you. Okay, now come to the next. The next is our square function. Okay, so the next is our square function. What is square function? Okay, now the next that we will do is square function. Okay, this is our square function. Okay, again, here f is a function that is defined from the set of real values to the real values. Okay, and this is function of the type fx equals to x square. Right, fx equal to x square. Okay, so here we will try to understand what's going to be the nature of this function and what's going to be the domain and range of the square function. Okay, now if you draw the curve for this function, okay, if you draw the curve for this function, then what will you get? Now see here, it says that, let's say that here here at x equal to 0, okay, I will get 0, right? Then f equal to 1. Now see here, f equal to 1, the value of this function, it's going to be, at x equal to 1, the value of this function, it's going to be 1. Now at x equal to minus 1, again the value is going to be 1. Same here, for x equal to 2, value it's going to be 4, and minus 2, the value is same 4. f3, it's going to be 9, and for my x equal to minus 3, again this is going to be 9, right? Then f4, it's going to be 16, and then x equal to minus 4, it's going to be 16 too. Okay, so what does it mean? It means that what's going to be the minimum value of this function? If you look at minimum value of this function, okay, forget about minimum value. Let's say that what can be, what values are, what's going to be its domain. Now clearly you can see here that you can input any value of x, means that this function can take any value of x. It can take negative values, negative values, it can take 0, it can take positive values, right? So there is no restriction on uh, on the values that it will take, as it will take in the form of its domain. Okay, so it is defined for all real numbers, and uh, if you try to plot all these values on the graph, then you're, for example, see here, at fx0 y0, f1 1 1 y1, and then uh, minus 1 1 minus 1 1 here, then this is 1, this is, let's say, 2, so here 2, and then here minus 1 minus 2, it's going to be here. Okay, so your graph will be something like this. Okay, your graph will be something like this. Okay, so your graph will look something like this. And what is this? This is the graph of fx equal to x square. Now this represents what? This represents the upward parabola, right? It is parabola, so it represents upward parabola. Okay, now domain is fine. Now see here, as far as domain is concerned, a df domain of this function, it can take any value. See here, I am taking negative values. Here for 0, I have defined it for 0, and then I also have defined this function for the positive value. So it means that it is going to take all the real values. So there is no restriction on any values when it comes to domain. Now let's look at the range of this function. Okay, now when you look at the range of this function, now it's interesting. Now see here, observe something here. The minimum value of range is here at x equal to 0. So this is going to be the minimum value of your range. Okay, and as you go towards the positive side of x-axis or the negative side of x-axis. So if you look at value of y, it's going to be positive. See here, x1, y positive, minus 1 positive, x positive, y positive, x negative, y still positive. Okay, so it means that the value of y, it's going to be positive. Okay, it will take 0 as the minimum value, and then it will go up to positive infinity. So the range, it's going to be 0 to positive infinity. Why here? Here close bracket, because the minimum value is 0 and it is included. So that's why range is from 0 to infinity. I hope it is clear to you. Okay, easy, not difficult, right? Now let's move to the next one. So after square function, we have what? Cubic function. All right. Okay, cubic function. Now we'll go to the next one, cubic function. Okay, cubic function. Again, your f is a function defined such f is a function such that it is defined from real values to the real values. Okay, now cubic function, it is of the type fx equal to fx equal to x cube. Okay, now we'll try to find out its domain and range. Okay, now cubic functions, when we did polynomials, graphs of polynomials, then there we have done the cubic functions. We have done the graphs of polynomials for degree 3, right? So cubic functions, they are of the type fx equal to x cube. Okay, so we will see the graph first. Okay, so here if you look at what possible values of x it can take, let's see, for 0, it's going to be 0. If you put x1, then it will give you 1. If you put x minus 1, you will get y minus 1. If you put here 2, then it's going to be 2. Y is going to be 8. Sorry, not 2, 8. And then minus 2 for x minus 2, you will get minus 8. Okay, so uh, here it's going to be 0. So your cubic function, it's going to be something like this. Okay, so this is your cubic function, which is fx equal to x cubed. Okay, uh, I have told you there too, if you want to draw the if you want to draw the curve for any of these functions using the accurate scale, what could be the possible way? uh, Please take more values of x, find more values of y, then map those values of x with the values of y, and then trace all the points. Then you will get some accurate on accurate scale, you will get the accurate curve. Okay, because here the shape may be a little bit distorted, but the main point is that you need to understand how the graph looks like, what's going to be the domain, what's going to be the range. Okay, so as you can see here, this graph, it is taking, see here, it is taking all the values on the negative side of x-axis. It is also taking all the values on the positive side of x-axis, plus this graph, it is also defined for x equal to 0. So it's very simple. The domain of this function, it's going to be the all real numbers. Okay, again, you look at the range of this function, so you can clearly see your y, it's taking the positive value. See here, positive side of y-axis, then on negative side of y-axis you also see the values. Okay, so it means that your range of this function, it is also all real numbers. Okay, so I hope this thing is clear to you. Okay, all right, now come to the next one. Next is our reciprocal function. Okay, what's the name of this? Sorry, forgot to tell you, this is cubic curve. Okay, this is cubic curve. Okay, now one more thing. How do we know if it's a function or not? The curve that you are getting, it's a function or not? I have told you last time, you can run vertical line test. Okay, you can just draw a vertical line anywhere on this graph. How many times does it pass through the curve? Only once. Only once. So if the vertical lines passes through curve once, then it means it's a function. If it passes more than once, then it means it is not a function, it is a relation. Okay, I hope you understand that point. Okay, so you can easily figure it out. The curve given to you, it's a function or not. Okay, so that's how we do it. Okay, so the next is our reciprocal function. Okay, so reciprocal function, it is very interesting function. Okay, so again, here we have x-axis, here we have our y-axis. Okay, so here we have our reciprocal function. This is our reciprocal function. Okay, so again, we have a function and it is defined from set of real values to the set of real values, and the reciprocal functions, they are of the type fx equals to 1 over x. Okay, so we'll try to understand the behavior of this reciprocal function. Now see here, 1 by x. Now when you look at, now this is the domain, and this is your range. Okay, when you look at the graph of the reciprocal function, the graph of reciprocal function is same as that of the graph of your rectangular hyperbola. Why? Because the two asymptotes, they are perpendicular to each other, right? So it's going to be something like this. Here and here, it's going to be something like this. Okay, so this is a graph of reciprocal function. And okay, so this is the graph of your reciprocal function. Okay, now see here, the thing about the reciprocal function is that this function, it is not defined for x equal to 0. Means here you cannot put x equal to 0. Why? Because if you try to do that, the moment you do it, your function is going to be not defined, right? Because we cannot define 1 by 0. Okay, so we cannot take x equal to 0. Now apart, if you look at this thing here, see here, it is not defined for x equal to 0. This is fx equal to 1 over x. So this function is not defined for x equal to 0. So what's, yes, if you look at this side, yes, it is taking the values of x on the negative side, is taking the value of x on the positive side, but there is no input when, sorry, x is not defined for 0. Okay, so it's going to be all real numbers except 0. So this is, you don't have to include 0. So this is going to be the domain. Okay, so here this is very similar to your rectangular hyperbola. It has two asymptotes. See here, asymptote here at x-axis, asymptote at y-axis, and these two asymptotes, they are perpendicular to each other. That's why it's known as rectangular hyperbola. In the coming times, we are going to have a very deep discussion on this, because this is this curve, this thing, rectangular hyperbola itself is very important topic. So when we will go to your coordinate geometry, circles, parabolas, we are going to have a separate discussion on this whole thing. Okay, so here just try to memorize, or just try to understand that the graph of reciprocal function, it looks exactly similar to rectangular hyperbola. So what's going to be the range? Again, the range, it's very simple. So x is not defined for 0, so it means that range, it's also going to be the same. So it's going to be r minus 0, right? So I hope you are clear with it. Okay, so range, as you can see, the values of y's on the positive y-axis, negative y-axis, right? But it's not defined for 0. Okay, so that's what about your reciprocal function. Now go to the next. The next is our modulus function. Again, we have a very deep discussion on modulus function. We also call it absolute value function. If you have missed that session, please, okay, I'm going to uh, put that link in the description too, so it's easy for you to figure out. We have several sessions on modulus function, so you can sit from there. Okay, if you have any doubts, or if you want to have detailed discussion, or if you want to have detailed session on a modulus function, you can go there. Okay, so modulus function. Okay, so this is modulus function. We also say it absolute value function. Okay, absolute value function. Okay, now again, this function is of the type fx equal to mod x. Now see here, So fx equal to mod x. Now this mod x, it has two values. Okay, see here, it is x if positive x if x is greater than equal to 0, and then it is minus x if x is less than 0. Okay, it is positive x if x is greater than 0. Again, the value is going to be positive. Now see here, do not confuse it. Now see here, what I'm trying to say here, if it is minus 5, okay, so for minus 5, now see here, it is less than 0, so it's going to be minus of minus 5, minus of x, okay, so that will make it positive 5. Okay, so the modulus function, absolute value functions, they are defined this way. Mod x will give you x if your x is greater than equal to 0, and it will give you minus x if your x is negative. Okay, so if you look at sorry, if you look at if you try to look for the domain of this function, now for x less than 0, okay, for it will take all the values. Even if x is 0, it will take negative values, it will take positive values, it will take, right? So it's going to take all the values. But the thing here is that the y, because the mod will always return you the positive values, right? So whatever your values of x, whether negative or positive, the value of y is always going to be positive. Okay, so for y equal to, this is y equal to x, and this is y equal to minus x. Now what are these? These are simply the straight lines. Okay, y equal to x, this represents y equal to x, right? And what is y equal to minus x? This represents y equal to minus x. Okay, y equal to minus x. So if you combine these two, then you will get, this is y equal to minus, sorry, this is y equal to x, this is y equal to minus x. So if we combine both of them, we will get this curve for y equal to mod x. Now when you look at this y equal to mod x, or fx equal to mod x, or fx equal to mod x, now see here, you have positive values of y. Okay, and for x you have negative, you have positive, and you have value 0. So it means that the domain, it's going to be minus infinity to plus infinity, or all real numbers. But the range of this function, it's going to be positive. Okay, so it will be 0 to infinity. Okay, so that's how you um, define the domain and range. Okay, so I hope this absolute value function, it is clear to you. Okay, it is nothing easy, because mod of, see here, mod of any negative number, it's always positive. Okay, so but this is parent absolute parent value function. It is defined in a way that mod x, it is x plus x, or x if x is greater than equal to 0, minus x if x is less than 0. So if x is less than 0, it is a negative value. So when you add this minus here, minus of minus, minus of minus, it's going to be plus. Okay, so just think logical. Okay, then next we have few questions that we will try to do. Okay, so the question, in the question, what we need to do is we need to use these concepts that we have to learn, and we need to find the domain and range. Okay, so first is fx equals to 1 over x square plus 2. So find, this is the function, we have to find domain and range. Okay, now see here. All right, now this is the function given to us. Okay, this is the function given to us. This is fx equal to 1 over x square plus 2. Okay, now we need to find its domain, means what values of x it can take. Okay, now if you look at this function, here in the denominator you have x squared plus 2. Now this is a kind of reciprocal function, right? Yes, because it is of the form 1 by x. But here in the denominator, we have the square of x. Okay, we have square of x. Now, because this is a kind of reciprocal function, so we have to make sure that this quantity, this thing x squared plus 2, this must not be equal to 0, because if this will become equal to 0, then this whole function will be not defined, right? So the chances of this thing going to 0, uh, is there any chance? No. Why? Because see here, you have here x square, right? So if you input any value of x, whether negative, positive, it will give you the positive value. Okay, so when you will get positive value here, then there is no possibility this whole thing x square plus 2, it's going to be 0, right? So in what scenario it can be 0? When your x square it's going to be minus 2. Now we know that x square it's a square function, and square function it has to, if you look at the range of the square function, the range of square function, the range is 0 to infinity. So it means that this is not possible, right? So it means that the domain of this function, it's going to be the all real numbers from minus infinity to positive infinity, right? Because this thing should not be 0, and we can see clearly that this will never be 0, because for this thing to be 0, x square, it must be minus 2, and x square cannot be minus 2, right? Because it is a square function. Okay, so your domain, it's going to be all real numbers. Now what about the range? Okay, what about the range? Now you have to find the range. Okay, you have to find the range of this function. Okay, now see here, let's start from here. Here we have x square, right? We have x square. Okay, now here I have said that the range of square function, it is from 0 to infinity, means that the minimum value of x square of any number is going to be positive or 0. So the minimum value, it will be 0, and it can go up to infinity, right? And it can go up to infinity. Okay, infinity, right? Now because I want to find the range for this, okay, the range for this. So what I can do here is that if my x square can take the minimum x square, range is from 0 to infinity, that's what it says, then what about x square plus 2? Now see here, because I want to find the range of this whole function, so if I get the range for x square plus 2, then I can take the reciprocal, right? And things will happen. That's what I believe. So let's do it for x square plus 2. Now if I add 2, both the sides, what will happen here? 2, and here infinity, right? Now if I do the reciprocal of this, now see here, we need to use some properties that we have learned before. The property says that, okay, it was, we have done it in the basic calculus, as far as I remember, yes. When we did some properties for 1 over x derived from x, right? So it says that when you have same signs on the both sides of the inequality, and you will take the reciprocal, then the sign of inequality will change. Okay, so what will happen here? If we take the reciprocal, then the sign will change, and here it's going to be this, and here 0. Okay, so now we need to find the the range for this, right? The range for this. So what's going to be the range for this? So your range, it's going to be from 0 to 0 to 0 to 1 by 2, right? 0 to 1 by 1 by 2. I hope this thing is clear to you. Okay, very simple. We started with x square. We know the definition of x square. X square, it's always going to be greater than equal to 0. Then we did nothing. We wanted to find the range of this function. If we know the range of this function, then we can do the reciprocals, and then we know lots of properties, and we know things will click. Okay, so what we did, I added to both sides. So when we added to both sides, we got this. Then when we took the reciprocal, because I have positive signs on the both sides, then what will happen? When I will do the reciprocal, the sign of inequality will change, right? So that's what I did. Okay, so your domain is going to be this, your range is going to be this. Now here you can see that we are making use of all the basics that we did before. Basics of calculus, very, very important. We have done around 10-12 sessions just to understand the basics that we are using here, and we are going to use in the future too. Okay, so functions are the basics of calculus. If you know domain of function, range of function, graph of function, behavior of function, then no one can stop you from learning the calculus. All right, now go to the next. The next one is fx is equal to here fx is equal to x square minus 3x plus 2 over x square minus 4x plus 3. Now, clearly you can see that in numerator and denominator we have quadratic, so we will try to find the factors. Here x square minus 2x minus x plus 2, here x square minus 3x minus x plus 3. Further, I can do x minus 2 minus 1 x minus 2, and here x minus x minus 3 minus 1 x minus 3, and here x minus 2 x minus 1, and here x minus 3 x minus 1. Now see here. So finally we have refined this function from this form to this form. Now see here, we have x minus 1 in the numerator, we have x minus 1 in the denominator. But if you look at this, maybe some of you, what they will do here is that you will just try to cancel both these things. Now, because the examiner who put this question, he did it for the purpose, right? So he knew that it can be factorized easily, and later these two factors will cancel each other. But that's not the purpose. But what he was more interested in is that instead of canceling these factors, how would you approach this problem? Okay, or what change it's going to bring if you do not cancel it here, or if you cancel it here, then how it's going to affect the domain and range. Okay, now clearly if you look at this function now, okay, this is the refined function. Okay, this is the refined function. Now clearly I can say one thing, that this function is not defined. It is not defined for this function. It's not defined for what? Not defined for x3 and x1. Okay, now imagine if you have cancelled it, then what would you have been left with? X by 2, x minus 2 by x minus 3, and then your function is not defined for just one value of x. What about 1? Right, so you must understand that if something is given to you that you feel like that this is absolute, I mean, there was no need of this thing, there must be some purpose that you have to look for. Okay, so it is not defined for x3 and x1. Okay, so from here I can say what I can say, that here from I can say that our domain, it's going to be all real numbers minus 1 and minus 1 and 3, right? Minus 1 and 3. And what's going to be the range? What about the range? Okay, what about the range? Now, this is, see here, if you understand why, because if I put 3 here, then in denominator, what 3 will make? 3 minus 3 will become 0, and this function is going to be not defined. Again, for 1 in denominator, we will get 0, which will make this function not defined. That's why we have excluded these two values from the domain. Now, what about the range? Okay, now, for what we can do here is that you're now, okay, now you can cancel it because now we have defined domain. So now you can cancel it, x minus 2 by x minus 3, because now your domain is already defined. So here, if what I do, it means y equal to x minus 2 by x minus 3. Okay, so if I bring it here, it's going to be xy minus 3y equal to x minus 2. And here, if I bring x here, so x, it's going to be y minus 1, and here 3y plus 2. Okay, so your x, it's going to be 3y plus 2 by y minus 1. Okay, now we need to observe this thing. Now try to observe this thing. Try to observe this thing. Now, see here, y cannot be 1. Why? Because if y, from here, y cannot be 1. If y is going to be 1, then this is going to be not defined, right? So we cannot take y equal to 1 here. So range is going to be 1. We don't have to take. Okay? And here in the range, we excluded these 2 points, right? Sorry, we excluded what? We excluded 1 and 3. Okay, x cannot be 1 and x cannot be 3. Okay, so here x cannot be 3. Why? Because if your x is going to be 3, then it's going to be not defined, right? But if your x is going to be 1, so we can check for if x is going to be 1, if x is going to be 1. Okay, see here, if your x is going to be 1, what's going to be the y? 1 minus 2 by 1 minus 3, which is minus 1 by minus 2, means 1 by 2. Because x cannot be 1, therefore y cannot be 1 by 2 from here. Okay, see here, x cannot be 1, so y cannot be 1 by 2. So yes, 1 by 2, y cannot be 1 by 2, and y cannot be 1 by 2. What about x cannot be 3? So here, because this is obvious, because if I put 3 here, then it's not defined. So there is no need to discuss this case. Why? Because that is already not defined, right? So x from here, y cannot be 1. And because x cannot be 1, so at x equal to 1, y is 1 by 2. So y should also not be 1 by 2. So it means that our range, it's going to be r minus here 1 by 2 and 1, right? So this is going to be your domain, and this is going to be your range. So I hope things are clear to you. Okay, so that's it, and I will see you next time. Okay, have a great time. Bye bye.